So I'll show you one application which is focused around the stock market, actually how to pick stocks. And I can tell you that, we did a very extensive study that showed that using very simplistic trading strategy based on sentiment, you can actually beat the S&P 500, and I'll talk about it later. And in the healthcare, I'll show you how you can analyze user forums and basically any textual content to find relationships between drugs, symptoms, diseases, etc. So let's go in. This is actually people that are familiar with text mining. I actually started the area of text mining back in '95, wrote the first paper on text mining. And this is actually an article that appeared about a year ago in Communications of the ACM. And the interesting thing, you can actually monitor how many times they download your article. So usually, if it's like a good article, they'll download it like 4,000 times, 5,000 times. That's a reasonable number for an article. So this article actually was downloaded 72,000 times. So it shows you how hot this area is. And I think really sentiment analysis is growing very fast. And there are really tons of applications, what you can do with it in almost any area. So as I said, I'll start with a very brief introduction. What is sentiment analysis, just for the benefit of the people that are not familiar with it. And then we'll go into the two specific applications. So the idea is really to study the opinions and sentiments of mostly people, but it might be also when an organization voices an opinion about any type of entity. And sometimes instead of sentiment analysis, it's called also opinion mining, but basically it means the same thing. So analyzing text in general is not an easy problem, and you can do it in many different ways. I can tell you that actually a lot of the commercial products that try to do sentiment analysis in many cases end up just counting positive and negative words. That usually doesn't give accurate results. And you can see why it's not really easy, and we'll talk about it more later, why it's not easy just to work at the word level. You really need to understand the semantics, the context in which something is written to understand really the meaning and if it's positive or negative. So you can see the first sentence definitely sounds positive, but when you add additional phrase, definitely it becomes mediocre. It's not negative, but it's definitely not a positive sentiment. So opinions you can get really for so many different things. It can be from call centers, emails that you may get, all the CRM. You get a lot of stuff from Twitter, Facebook, news articles, blogs. So today there is no shortage of opinions that people have. And I think everybody, when they try to buy any product on the internet, they first go to all different websites, Amazon, just to read what other people say about the products. And I know I definitely do it. And in many cases, my purchase decisions are better because I read the feedback of what other people have to say about it. So this is why really sentiment is extremely important, and you definitely want to analyze it very accurately. So there are many different applications, and when I talk about sentiment, I even take it to a little broader context. One of the interesting applications that we actually developed is an application for Standard & Poor's. So Standard & Poor's is one of the main rating agencies, and they basically give rating to any bond, almost any bond offering in the market, and they wanted to identify risk factors within the company reports. So to identify the risk, this is also, it's type of a sentiment analysis. Not that somebody gave an opinion, but you try to mine what the company wrote in the MD&A, the management discussion and analysis, and figure out where are the hidden risks inside. So this is why I view sentiment analysis in a more broad way, where you try to identify all sorts of issues within textual documents. So let's take an example of a review and see why sentiment analysis can be extremely tricky. So you can see this talks about an iPhone, and it talks about all sorts of features of the iPhone, like the touch screen, the voice, and then it moves actually to talk about a different product, about the BlackBerry. So if you take the whole document as one unit and basically just count how many times you have positive or negative words, you'll definitely miss completely what's written here. Here it's very positive about the iPhone, pretty negative about BlackBerry, and unless you know to identify the entities and what sentiment refers to each entity, you'll really get completely wrong sentiment. And I can tell you that a lot of the commercial products actually take the whole thing. If iPhone is mentioned there, they'll count every possible sentiment that is there, even if it doesn't even refer to iPhone at all. It refers to a totally different entity. So this was really a very brief overview of what is sentiment analysis. And what I'll do now is I'll go into two applications that will show you what can you do with sentiment analysis in the real world. So we'll start by utilizing news sites to do sentiment analysis of stocks. So we actually created a system called the stock Sonar. You can actually go to the web, thestocksonar.com, and you can play with it. And I'll show you basically what you do with something like that. So first, let me convince you that you really need deep linguistic analysis in order to identify what is the positive and negative sentiment about each stock. So let's take this sentence about Toyota. So most of the words that actually appear in the sentence are positive, right? So if you just use a dictionary-based approach and count how many times you have a positive word and how many times you have a negative word, you'll decide that this is a positive sentence for Toyota. Obviously, it's a horrible sentence for Toyota. Everybody remembers the big recall problem that they had. So the idea is you want to identify the recall event. Once you identify the recall event, you know that this is, a recall can never be positive. So we know about all the problems that Toyota had, all the problems that GM keeps having with more and more recalls. So we definitely know that recall is a bad thing. You want to identify it as an event. And then all the other positive things are not really positive. So let me explain you the architecture of the system. And this is a typical architecture of a sentiment analysis system. So the input to the system is basically the ticker. Yeah? If you want to analyze Citibank, it will be C, Bank of America, BAC, etc. What we do is we then go to 5 major sites. 3 of them are hubs. Google Finance, Yahoo Finance, MSN Money are the hubs. So you know they don't have their own content. Yahoo Finance has some of its content, but Google Finance basically is just a bunch of links. When you put the ticker, you get links to many different sites. So they don't have their own content. You actually have to go to any individual site and pull the content from the site. In addition to those 3 major hubs, we also use Seeking Alpha, which is a premier financial blogging site. I can tell you that based on research that we did, especially for small stocks, it can be that one article that is published on Seeking Alpha can give a really very strong movement in the stock, either up or down. And the last one is Benzinga, which is mostly for analyst recommendations. So we get the content from, so basically I mentioned 5 sites, but since 3 of them are hubs, we're actually talking about hundreds or sometimes even thousands of financial sites that we are visiting. The first step is actually to clean the HTML, because you don't want to use all the advertisements, all the related links, so there is a lot of garbage on the page that you don't care about. So I'll just jump to explain this step. So here, we actually built a machine learning system to train the system to recognize what is the relevant content. So the training is done visually. We basically analyze the DOM tree. So we take the structure of the page, and based on the analysis of the DOM tree, we can actually, initially we just have to take around 50 pages and just click red or green. Red, it means the whole frame is not relevant. And usually it's like a zigzag, because you said the whole thing is not relevant, but this is relevant. But this inside is not relevant. So usually it will be like a zigzag operation. And finally, you'll basically mark all the different frames that are relevant. After you marked all of those for 50 different pages, and it doesn't matter from which sites. It can be from any site. We actually did experiments where we taught the system on a marathon training and tested it on subprime lending. It's totally different domain. Still, we managed to get over 97% F1, which is the harmonic average between precision and recall. And that's because we don't utilize at all the words that are written inside. So we are totally content agnostic. We really analyzed just the style of the structure of the page. And based on that, we can actually learn what is important and what is not important just based on those 50 pages. And from that, we actually get just the relevant, just the clean content. Now we go to the next very important step, which is identifying for each entity what is really the relevant text for that entity. As I showed you before on the review on the iPhone, part of the review referred to the iPhone, part of the review referred to BlackBerry. So you want to identify within the article what are really the sentences, sometimes the phrases that are relevant to that entity. That step usually is totally ignored, and it's extremely important. We actually showed in a research that we just finished that you improve the accuracy from 23% when you actually do it in a very naive way to 92%. So it's really a huge difference when you really do this relevance analysis in a very careful way. This is also based on machine learning. It's actually based on conditional random fields. So it's a sequence classifier that is able to identify very precisely what is the relevant text for each entity. And then, after you know what is the clean and relevant text for each entity, now you really start the sentiment analysis. So we use 3 different algorithms that basically utilize different types of content. They work at 3 different levels. So we utilize, let me actually jump 2 slides. So the first and the most simple one is the lexical based. So there we actually utilize sentiment dictionaries. Actually, in the article that I showed you from Communications of the ACM, where actually I listed the main sentiment dictionaries that are available. And we actually took all of them. And using machine learning algorithms, we found what is the best sentiment dictionary for the financial industry. Definitely for each industry, you need to create a different sentiment lexicon. You cannot have a generic lexicon that will apply to all the industries. It's very clear, for instance, usually when something rises in the financial market, usually that's a good thing. But if your blood pressure rises, usually that's a bad thing. So it's very contextual, and you cannot use the same sentiment lexicon for all the domains. You definitely have to do a very serious customization in order to use the right dictionary, the right lexicon for the specific domain that you are working on. Then there are all sorts of combination rules or patterns. So I'll give you an example. The verb reduce. The verb reduce by itself is a negative verb. So it depends what is the noun that we are reducing. If we are reducing a forecast, then it's negative. But if we are reducing expenses, that's positive. So if we'll try to generalize it, forecast is a positive noun. So we have negative, positive, that's negative. Expenses are negative. So we have negative, negative, and this is why it's positive. So basically combination rules like that would be in this area. And we have a few dozen combination rules like that that basically enable us to just utilize small lexicons to identify the correct sentiment. Finally, there are the events. And the events, we have over 70 different types of business events that we can detect. By the way, we learn the specific events just by doing unsupervised relation extraction from the web. I mean, the classic approach is actually to utilize rules, but that takes way too much time. So what we did is we use machine learning actually to do it. So you actually take the text, you identify what are the main entities that are inside the text, and then you learn just by using a parsing of the sentence structure, you learn what are all the possible relationships between the entities. Then, after the system generated, so the system actually generates the code for you for detecting every possible relationships between the entities. By the way, the entity types, you actually have three options how to define entities. You can either use lexicons, you can use rules if you want to define the entities, or you can use, again, a CRF classifier. You provide tagged XML documents, and then the system will learn a CRF model to tag new documents that it never saw before. So once you identified all those different entities, you can actually learn all those relationships, and from that you can actually find the events. So basically all those events, we didn't have to write a single rule to extract them. They were all learned just by utilizing a very large financial corpus. So this is this step, okay? This is the step of the sentiment analysis. Now, you want to score, based on all the sentiment analysis that you did, you want to score the document for that particular stock. And the score would be between -1 and 1. -1, it means basically everything that was written about the stock is really bad. 1, everything that was written about the stock is really good, and there is not even one single bad word. Usually, of course, the score would be somewhere in between -1 and 1. You'll see the scores very soon. So after we did this, we actually utilize, it's not that we have only one document. In many cases, we'll have thousands of documents or sometimes millions of documents. So we take everything into account. You can actually take into account who wrote the article, what is the source. So you can say, if something was published on Bloomberg, it's more important than some private financial blog that I'm not sure who wrote it. So definitely you can give different importance to different sources. And also the time when it was published is extremely important. There is a decaying effect. So basically like a day later, after an article was published, probably it's much less important than it was the day it was published, and it really goes exponentially down as you move from the day of publication. So here are just some examples of what we have in the lexicon. So there are over 8,000 words for the financial lexicon, things like what you see here. Here are some examples of the event-based that were learned by the unsupervised relation extraction. And this is actually how the system looks like. And you can see for each one, you'll see for each stock, it shows you what is the type of the event that happened, if it's positive or negative for the company. In addition, you can actually click to see the original article, and then it will highlight for you in red if it's a negative sentiment, and in green if it's positive sentiment. Okay? Now, what can we do with it? How can we use it for trading? So here you can see, for instance, Teva. It's a very famous Israeli pharmaceutical company, famous for the Copaxone. And usually what we look for is actually, so let me first explain what are the three lines that we see here. So the green line is the positive sentiment, the red line is the negative sentiment, and the blue line is the stock price. So what you can see is we're looking for spikes in either the positive or the negative sentiment. If we see a spike, and actually the market is going down, usually that would be a buy opportunity. If we see a spike in the negative and the market is going up, that would be a going short opportunity. So let me show you a few more examples. Mosaic, in the agriculture space, you can see very big jump in the positive sentiment, but the market didn't move at all. You see all the move actually happened later. When you go to an MBA program, usually they teach you in the finance class that the market is efficient. Well, it's not always efficient. The idea is really to try to identify all those inefficiencies in the market and take advantage of that. SanDisk, also very similar to what we saw before. This is for the negative side. You can see General Motors. So you can see, again, the market didn't move even though there was a spike. And a few days later, it actually started to move down. Micron, by the way, you can see how much time we are following it. Now, here it was $6. People that follow Micron, it's like over $32, something like that. So definitely, that was a very good peak of the system. Cliff Natural. This is actually my favorite example for a pair trading, Macy's and JCPenney. So Macy's, you can see, was definitely positive here, and Macy's actually is above $60 already, so it's 3 times from what you see here. And JCPenney, on the other hand, is around $10. It was even much less a few months ago. So definitely just by going long Macy's, short JCPenney, you could have done like 6 or 8 times on your money. This is actually an example where you can see the market reacted immediately when the news came out. So it's too late. There's nothing that you can do. You move on. So this is a classic. And usually, this is what will happen. So if the market really moves when the news is out, there's not much that you can do. This is a textbook example for Monsanto, also in the agriculture business. And you can see really very nicely how the system peaked when actually there is a very long downturn. You can see that when the stock actually started to move up, the system did not pick it up. We can take only the information that we have in the text. In many cases, they might be that a stock is becoming too cheap, and then some hedge funds or other people decide that it's cheap enough, they want to go in. There is no news that will justify it. So the system basically picks only the signal that we get based on the text. Of course, any trader knows you cannot do everything just based on one signal. You want to use many signals, technical analysis, volume analysis, etc. Fundamental analysis. So this is about the financial sector. As I mentioned, a very similar system that we did for S&P really monitors every possible filing that gets to the SEC, and within 20 seconds from the filing, the analyst will get a very detailed analysis. What are all the risks that were found inside the report, whether it's 10K, 10Q, etc. And actually now we're also rolling it for Spanish for the Mexican stock exchange. Let's move now to the next application, which is mining medical user forums. So the process is very similar to what we saw before. We need to identify what we're interested to mine. So in this case, we wanted to mine diabetes user forums. So we identified what are the major diabetes user forums and downloaded all the messages from all the forums. Then you need to clean it. You need to identify the units. In a user forum, you have threads, you have messages, sentences, so we need to do all this analysis. And then you want to identify what are all the main entities that you have inside. So the entities would be drugs, symptoms, maybe names of doctors. So those are really the main entities that you care about. And also you care about comparisons. Somebody will say, I prefer to use this drug over this drug because this drug gives me whatever. So this is the type of information that basically we want to get out of it. Those are the main forums for diabetes that we found, and we basically downloaded all the messages that we found here. What you can do now is you can actually draw the graphs. You can see all the graphs that show you, in this case, the co-occurrences. So in this case, it's not semantic yet. You basically just look that two drugs will appear within the same message. Usually, if they would appear within the same, there is some connection, but it's not doesn't have to be a semantic connection. We will show later that when we use actually the semantic connections, we actually get more information out of it. So now we can actually see what we can do when we are interested in drugs that are taken together. So now you can see the graphs. If there is a line, it means that those two drugs were taken together. And basically, the width of the line also shows you how many times they appear together. Here you can see when people said that they switched from one to another. Also, the width shows you how many times people said that they switched from one to another. And now you get to the side effects. The width here shows the lift. The lift basically represents what is the amount of surprise that we get when we use the drug and we get the symptom. So you can see that there is a very strong connection between Bayeta and runny nose. You can see that doesn't work actually has a lift only of 1, which is basically just the common thing. There's no extra information that we got. Everything that is above 1, it means that actually we have extra information. Now you can take a few drugs and you can see which side effects are actually shared by multiple drugs. So you can really do a very nice market analysis just by looking at every possible graph that shows the connections between the drugs and the symptoms. You can also see here the positive sentiments that we get. You can see that we had a lift of 17.5 that Bayeta helps with hunger. It means that it's a very significant, something that is extremely statistically valid based on all the analysis of the forums. Again, you can do it in the context of the network. And I'm just rushing to, so I think I'll stop here, right? And we'll take some questions. I'll just mention one last thing that we actually did. We have a database of 15,000 medical experts, and we are actually monitoring daily what are those experts saying about any of the drugs with regard to efficacy, tolerability, safety, and cost. So this is actually a report that the pharmaceutical companies are extremely interested in getting, and this is actually based when we utilize Google together with the text mining and the sentiment analysis to generate this report.